Looking for planets where life could develop is one of the major long-term goals of current studies of planets around other stars. In this question, we'll look at some of the criteria that astronomers look at when they try to identify potentially habitable planets. You'll be looking at your inner planets and deciding which planet seems to give the best chance for life to exist on its surface. You should also pick at least two other inner planets and try to decide what makes them less good choices. Note that it's possible that none of the planets in your system have good conditions for life, in which case you should describe what is wrong with at least three of these planets. One thing to keep in mind with this question is that you're not necessarily going to find a planet that humans can live on. Life can be any kind of life, even if it's just bacteria. Remember that throughout your answers, you should always refer back to the data and any calculations you made to support your conclusions. When studying terrestrial planets, the first thing astronomers look for in searching for signs of a habitable planet is liquid water. In our own solar system, liquid water is fairly rare in the inner solar system, and yet it's absolutely essential for life here on Earth. So the most important question you should ask in this assignment is whether or not it's possible to have liquid water on the surface. The first criterion for water is that the planet's surface temperature has to be reasonable. Earlier, we simply used the range of temperatures water can be a liquid, 270 to 370 Kelvin, to define this. But now we should look at this more carefully. You should calculate the planet's surface temperature using Wien's law. Remember that when you do this calculation, you're finding a global average temperature. On Earth, the global average temperature is about 290 Kelvin, or about 60 degrees Fahrenheit. However, parts of the Earth get much hotter than this, while other parts are much cooler. So realistically, the average surface temperature can be as low as 250 Kelvin, or minus 10 Fahrenheit, and there would still be a chance of finding liquid water in the warmer equatorial parts of the planet. The boiling point of water depends strongly on the air pressure. The thicker the atmosphere, the higher the boiling point. However, even if the air pressure is high enough to allow liquid water at 400 or 500 Kelvin, it's not clear how well organic molecules could survive these conditions. Also, the evaporation rate as temperature goes up can be very high. So while water isn't boiling, it may still be evaporating off the surface too quickly to allow water to remain a liquid. So if the global average temperature is much above 350 Kelvin, it's unlikely that there will be much liquid water on the surface. If the air pressure is low, then this limit will be lower as well. That raises the next point about water. Since the boiling point of water depends on pressure, it's important that there be enough atmosphere for water to be stable at all. You should look at how much greenhouse warming a planet has and use that to estimate if it has much of an atmosphere at all. If there's much less than 10 Kelvin of greenhouse warming, the atmosphere is probably thin enough that water boils away even at very low temperature. Having a thick atmosphere also protects living organisms from the high-energy parts of their star's light. So an atmosphere is clearly a key part of making a terrestrial planet habitable. There are other factors that can play a role in helping you decide which planet is most likely to have life. While these mostly aren't make or break for life, they can improve or worsen the odds that life will start, and they could also help determine if life evolves into more complex, multicellular organisms. The first thing to look at is the planet's geologic activity. An active geologic surface is necessary for maintaining a working carbon cycle in the planet's atmosphere, which is key to giving stable atmospheric temperatures over a long time period. So the planet should be large enough that it still has active volcanoes. It's likely that any planet that has substantial greenhouse warming will also fit this criterion, but it's worth checking. The planet's spin can also be important here. Some planets spin very slowly, taking thousands of hours to give one rotation. This gives large day-night temperature swings. Even though the average temperature may be reasonable for life, if the surface goes from boiling to freezing every day, it may be hard for life to form and develop there. An extreme case of this is a planet that spins at the same rate it orbits, causing it to keep one face towards the star the same way the Earth's moon keeps one face towards the Earth. This would mean one side of the planet would be in perpetual sunlight, while the other side would experience constant night. It may be that the only potentially habitable part of such a planet would be a thin band between the day and night sides of the planet. Finally, looking at how extreme the seasons are could also be important here. If the planet has a very large tilt and hence very extreme seasons, then the temperature at any one location could change very dramatically through the year, making it harder for life to develop.